All right, so today we're looking at a piece of hardware that solves a very specific, and I think we can all agree, a pretty rage-inducing problem.
Hmm.
But it has a name that only an engineer could love. The NTI DP-HP-MNTR-SRC.
It's a mouthful.
It really is. It's a DisplayPort Hotplug maintainer. And if you use a KVM switch and you're tired of your desktop window scrambling every single time you toggle between computers, well, this is the deep dive for you.
Yeah, it is a niche device, for
Yeah.
sure. But for a certain kind of power user, it's absolutely critical. Our mission here is to understand how this little dongle, this glorified middleman, basically tricks your GPU into thinking everything is fine.
The core promise is pretty simple then. It just stops your computer from, completely forgetting the monitor exists. But let's get into the why. This is all about the hot plug detect signal, right? HPD.
That's it exactly. In a typical setup, when you switch your KVM from, say, your work laptop to your gaming rig,
Or whatever, yeah.
you are, for all intents and purposes, severing that connection. So the HPD signal, it just drops. Your operating system sees that drop and assumes the monitor is gone for good.
And that's the panic moment. That's
Yeah.
when the chaos happens. The OS looks around, sees no destination for your windows, and just shoves everything onto a different screen or into some generic grid.
Precisely. It's an aggressive reconfiguration that just ruins your workflow.
So what this NTI maintainer does is it emulates that signal.
It does. It sits between the video source, your PC, and the KVM switch.
Yeah.
So even when you toggle away, this little device keeps the voltage high on that HPD pin.
So to the computer, the monitor never left. It's like a ghost monitor. But here's the thing. If it were just a simple resistor keeping a pin high, you could just buy a $5 dummy plug.
Right.
This NTI unit is priced around $150. That tells me it's doing something much, much more complex with the data.
That is the crucial distinction. A cheap dummy plug usually doesn't pass video through to a real monitor, it just fakes ahead.
Oh, okay.
This device has to pass the signal through to the real screen while also maintaining the fake signal for the PC. And that means handling massive bandwidth without degrading the signal at all.
And looking at the datasheet, it supports DisplayPort v1.4. So we're not just talking about keeping a connection alive, we're talking about HBR3 high bitrate 3.
Which is 32.4 gigabits per second. That is a lot of traffic to manage transparently.
Yeah, if this thing introduced any latency or signal noise, you'd get flickering blackouts.
All sorts of problems.
Oh.
But it supports resolutions up to 8K at 30 hertz.
Or, for the performance users, 4K at 60 hertz and even 1080p at 120 hertz. That 120 hertz support is key.
It is, because so many of these other pass-through adapters cap you at 60 hertz, which just kills the experience if you're gaming or doing high-end video work.
And it claims to be completely transparent to all the metadata, too. HDR 10-bit deep color.
Yeah, it just passes all of it right through, both RGB and YCC color standards.
That's vital. You don't want to fix your window arrangement only to completely destroy your color grading accuracy. Now, physically, this thing is tiny. It's about 1 inch by 2.5 inches. And what's surprising, it's bus-powered.
Right, no wall wart. It pulls the 3.3 volts it needs directly from the DisplayPort source. That is a huge advantage for cable management.
Oh, absolutely. They also include a 1-foot extension cable, which sounds trivial, but have you actually looked at the back of a modern GPU?
It's a mess. The ports are jammed right up against each other.
Yeah. If this was some wide dongle plugging directly into the card, it would probably block the adjacent ports. That little extension cable is a clear nod to the reality of how people build PCs.
It is, and it also supports headless operation. So if you have a render server or, a mining rig that you usually access remotely.
This keeps the GPU active and rendering at full resolution even when a screen isn't physically connected. So the value proposition here is essentially time and sanity. For about $150, you eliminate those 10 seconds of rearranging windows every single time you switch inputs.
It just smoothens the entire workflow. You switch away, you switch back, and the pickles are exactly where you left them. It eliminates that digital handshake lag completely.
It's a hardware fix for what really feels like a software annoyance. But it does make you wonder, doesn't it?
It does.
We have AI processors and 8K screens, yet the basic protocol for "is a monitor connected" is still so fragile that we need a dedicated emulator to fix it.
It raises a valid question about our standards. Why does the operating system assume that just because a signal dropped for 2 seconds, the monitor has ceased to exist?
We're building smarter displays, but the communication protocol between them and the PC, it still feels kind of stuck in the 90s.
It really does. It's like we've forgotten about object permanence.
Something to chew on the next time your icons decide to play musical chairs. Thanks for listening to this deep dive.